Hey, Mr. Stocking here, looking at the essay that we went over this morning with battery electric vehicles, also called BEVs, and ICE vehicles, internal combustion engines. Those are typically your gas cars. The question was, identify 3 strategies that the federal government could implement to encourage the use of BEVs. Well, you could increase the subsidies for BEVs. So, like you get a tax break when you install those or you buy one. Or you could decrease the subsidies for ICE, like charge more for gasoline. Okay, you could put a tax on gasoline or diesel fuel. You could also increase subsidies for power companies, so that would be electricity is cheaper, okay, than gasoline, than buying gasoline. You can make charging stations more accessible. You could allow BEVs to use the HOV lane. That's a high occupancy vehicle in there. You could make tax incentives for purchasing home charging stations. So if you wanted to charge your car at home, make it, the system costs $1,000, and the government will give you $800 back on that, tax-wise. So this is a tough question because you may not be used to subsidies or understand tax laws or anything like that yet. But let's go into the math. So, assuming that our car gets 25 miles per gallon, and we know it's an ICE car, and it costs $3.75 per gallon. What you're doing is dividing $3.75 by 25 miles per gallon. Okay, this dollars. And then what you can do is divide 25 by 375, and after you do that math, you'll find out that it's 15, and then bring the decimal up. It's 15 cents per mile, okay, and that makes sense. Another way to look at it is how many times does 25 go into 375, and that number is 15. Move the decimal over, and then you'll get your number as 15 cents again. So for every mile you drive, it costs you 15 cents. Now let's look at a BEV. So we know to charge the BEV vehicle, it is 6 kilowatts. 6 kilowatts per hour. Okay, that's what it takes to charge it. And its charge time is 5 hours. So you end up using 6 times 5, 30 kilowatt hours to charge your car. Okay. Now the electricity costs 10 cents per kilowatt hour. There's my 10 cents. And what we're looking for per kilowatt hour, those cancel, 30 times 0.1 is $3. Okay, that's what it costs you to charge your car, which is pretty close to that. But the upside here is you're not going 25 miles, you're going 100 miles. So the cost of electricity per mile to drive that is $3 divided by 100 miles. And what you'll find is that is 3, move the decimal over 2, you're actually only paying 3 cents for that per mile. That's a lot better. How many times better is that? That's 5 times better than this ICE car. Okay, so let's move on to this question, which is right here. Calculate the difference in the amount of CO2 that would enter the atmosphere if both cars were driven 100 miles. Okay, literally it's looking at the numbers and adding them up. It's not that hard. I'll slide the answer in here. We are looking at 72 pounds of carbon for the ICE, and we have this for the other one, so we have to add those two together, and we'll get 90.5 pounds, and then we subtract that 63.6 from the BEV car. So that's our ICE, and this is our BEV car, and our answer is 26.9 pounds. That's every 100 miles what we would be saving. Pretty impressive amount. Now we have the last question, which is describe 2 economic impacts. Keyword, economic, not environmental. Okay, so what the answer is here is that will result in an increase for the number of BEVs on the road. Okay, so if we had more battery cars on the road than we would gas, let's take a look at some things that would happen. Now, economic impacts. Notice that it didn't say that it had to be a positive economic impact. It could also be a negative. Some of the negatives would be, well, we'd lose some jobs in the petroleum industry, in the gas industry. We'd lose jobs in the manufacturing of cars, ICE cars, or the repair of ICE cars. Okay, we would decrease in revenue from gas tax. Okay, we would lose that. These are our losses, economic minuses. Now, economic pluses, what we would do is we would increase jobs profits for the electrical company. Obviously, there's more BEVs on the road, so we need more electricity. We'd have an increase in jobs or profit for manufacturing of those BEVs or repairing of those BEVs, more repair shops. You know, I'm sure they're complicated, those cars. The increase in price of electricity or fuel used to generate electricity because of the increased demand, supply demand. If demand goes up, then supply goes down, then the cost is going to go up. Okay. There's a few other examples on here that you can push pause and read through. All right, hopefully that was helpful. Thank you.